when the equation is in standard form. First of all, what is standard form? Right, this is ax squared plus bx plus c equals y, or f of x. When we are in that form, what do we already know? We know the y-intercept. The y-intercept equals c, right? Why do we know that? Because x equals 0. So these two drop out. Excellent. What else do we know just from looking at that? There's one other thing we know without doing any math to it. Oh yeah, of course. There's actually a couple of other things we know. We know the domain automatically. Thank you, Joel. I'm going to just leave that one out because that's something we always know. Okay, Lucas. Yes, you know from if A is positive, what kind of parabola is it? Opening that way with a minimum. If A is negative, then what is it? Opening that way with a maximum. Do you know anything else from that by itself without doing math? No. What can you do with this? You might be able to factor it. You might be able to complete the square. You might be able to you're always able to quad formula. And you can get the axis of symmetry. If you do find the vertex. Oops, not the vex. Axis of symmetry from doing what gets us the axis of symmetry? Negative b over 2a. That is what you can do with the standard form. Everybody okay with that? This sheet is going to be your best friend when it comes time to study for the next test. It should already be filled out. When the equation is in vertex form, vertex form looks like what? Y equals A bracket X minus Q or P. I can never remember which it is. It's P in that one, right? Plus Q. What do we know? We know A still works. That way, whichever it is, positive, negative. What else do we know? Right, we know the vertex. Vertex is PQ. But what do we have to remember? Opposite sign. Opposite sign P. Do we know anything else here? Something else about A that we actually forgot in the first one. Pardon? Yeah. A is I like to call it our stretch factor. Now, what math can I do there? Can I do anything with it? I can use this to find intercepts by subbing in, right? So I can find intercepts by subbing in. I can also expand into standard form. And then I can do all this stuff. Everybody cool? Okay. And finally, factored form. What does factored form look like? A, X plus Q, X plus P. What does that tell us?
The 2 points with the intercept.
Yeah, this gives us the roots.
But opposite.
The roots are x plus q equals 0 and x plus p equals 0. Okay? I don't want to say what you said, Bryce, because sometimes you have to solve it, right? If it was 2x minus 1, the root is positive 1/2, right? You got to solve it. It's not just the opposite sign. Understand? Okay. You cool? Okay.
I wasn't super offended that you didn't use my words.
I know.
I wasn't crying about it, but...
I know. What else do we know? Do we still have A? A is still working for us. What else do we know? Does this tell me the vertex? How? Does it give me the whole vertex, I should say? What? You got to do some work. It gives me the vertex X. How? Q plus P divided by 2. And then what math can I do? Once I have the Vx, I can sub in for Vy. Right? Okay. Is everybody good with that sheet? I would put a little marker, fold the page, do something with it where IU, because that's a pretty important sheet for studying purposes. Cool? Okay. Now, I left a bunch of blank space down here for any other questions or things about parabolas with which you are concerned. I'm going to write a couple of things here that every kid screws up. Okay? Domain. X is all real numbers, but watch out for real life. Right? You've got to use your brain. If you're charting time, can you have negatives? No, so that domain isn't all real numbers, is it? Only the positives, right? So you got to keep your eye on that. Okay? Well, you would say x is greater than or equal to 0. But the other thing you have to be aware of is sometimes parts of it don't matter, right? For example, if you jump out of a plane, you have a parabolic curve to your height, yes? What happens when you pull the parachute? Does that curve change? Does the curve change? Yeah. So the domain is going to be weird, right? You just got to keep your eye on stuff like that. Watch out for real life. That's something kids screw up a lot. Range. This is a minimum. So my ranges must be greater than or equal to my vertex y. This is a maximum. So my ranges must be less than or equal to my vertex y. That's another thing kids screw up. Okay? And I'm just basing this on marking tests. From old tests from previous years I've taught this. These are things that kids mess up on. Okay? This is A is positive. This is A is negative. The next thing kids mess up on is the stretch. A regular parabola, y equals x squared. If I go 1, 1, 2, what's this? 4, 3, 9. It's always squared, yes? This value is multiplied by A. Whatever A is. If A is 1/3, Which of these 3 points are you easily able to put on the graph if A is 1/3? Just that one. And it would be over 3 up 3, right? What if it was half? Which one of these would you use? 2 and 4, because it would be over 2 up 2. What if it was 6? Well, you could use any of them if it's 6, because that's going up. Over 1 up 6, over 2 up 24, over 3 up 54. Everybody good? What if they're negative? What happens to these? It goes down. Does the value change? No. Is everybody cool with page 110? Learn it, live it, love it. A few people have already asked about this. Now, guys, I don't know about you, but in a perfect world, we are really done with quadratics. This next page that you guys have, page 114 and page 114, is all calculator work because it's using weird numbers, okay? So here is what I would like to do. I would like to go on to 114, 115, okay? I would like to go on to that, give you all a calculator, do those as notes, and then shut up and let you work on page 116, 17, 18, and 19, because that's your review for your big test that covers everything. That will be for marks. Now, if we get through 114 and 115 with the calculators, if we get through that very quickly, I can come back and actually do this in class today. If we don't, then I'll put this on video like I did yesterday. Is that cool for everyone? Okay. Now, I don't know. I went and watched that video last night to check how many of you had viewed it because I'm insecure that way. I'm not really. I just like to know sometimes. And when I watched it, I noticed there was no sound. Was that on my machine or was there no sound? Because I don't have speakers on my home computer. So, but I didn't see the volume thing going up and down, which when I turned on my missing speakers. So was there sound? Okay, so obviously something got screwed up in the recording. If that messed you up, I apologize. I'll double check today. If there's no sound there, I'll have to go back in and find out what the hell's going on. Okay? I don't know. That whole thing we just did. Shut up. No way. No, we're cool. Look. Because, see, this is going up. Shut up. Yeah, but I did that other thing later. So it's entirely possible that when I hit stop or pause or something, I hit this little microphone button. Maybe. Let's see what happens if I hit it now. Yeah, that's what it was. Okay, so we're set. Is everyone cool with doing it that way? So we'll go ahead and we'll do 114, 115 together right now. See where that takes us.
I wanted that one question.
And then, well, Bryce, it shouldn't take long. You guys are getting pretty good. So everyone needs a calculator. Drop off a phone, grab a calculator. Let's get on with this.
Are we? We all just sat in silence. We asked what roots were.
I know, I'm a little worried, but... Who doesn't love that song? I'm a little bothered by that commercial that makes fun of that song where the guy's got 4 pleats.
I love that song.
It's a fun song.
It's so happy and it reminds me of something.
I don't know what we're talking about.
The Partridge Family song?
Oh.
How does it start, Joel? Got go for a walk outside. The summer sun's calling my name. Stay inside all day. Come on, Bryce. Take it.
I'm trying to remember the words.
Gotta get out. Catch me some of those rays.
I know the tune better than I know the actual
I'm
words.
extra happy today because on the radio show I listen to in the morning, She plays one song from back in the old days, and the song she played today was ABC. Which, if you are not a fan of the Jackson 5, you don't know anything about music. And we know Jordan doesn't like music, so. Jackson 5. ABC. Easy as 1, 2, 3. Simple as do, re, mi. ABC. You have nothing? Nothing.
Really? You've never even heard someone
Nothing.
sing that?
You've never heard that. No. All right. No, I'm not playing that. We're going to finish today's stuff. Now, has everybody got their calculator handy?
Yeah.
Huh?
But what you just said.
So many people. I in my life, since all these roundabouts have shown up, I see, and now I'm not being ageist, okay? But I have seen now there are 2 roundabouts in Chilliwack, 2 big ones, and there's all the ones around here. I have seen, since they were all put in, at 11 times people going the wrong way around the roundabouts. 9 of those 11 times, they were old people. 2 of those 11 times, they were very, very young people.
Because they don't make you go on roundabouts, so like, the only reason I don't go on roundabouts is like driving lessons, other than that, like,
Okay.
You go in a circle.
It's called a roundabout, and you have to enter it on the right-hand side of the road because we drive in Canada. So when you enter a circle on the right, you must continue to drive around the roundabout. That's why it's called a roundabout. It's not a hexagonabout.
The thing that was sad though is the fact that she told me to turn back because she meant like after the roundabout we go left. And so then he went and he was like, oh, there was no oncoming traffic, so I just went.
Do I know this kid?
No.
Okay. All right. Okay. So here we go. Now, guys, I know that as always, you feel that math and algebra really have no place in real life. Every time I do questions like this, some kid in the class says, why would you ever do that? Why wouldn't you just go get, because this question is buying fence, right? Why wouldn't you just go get a bunch of fence and just build it like 20 times and then decide then what's the big... And they honestly believe that's the right decision, rather than doing 5 minutes of math and building it right once. Okay? I'll give you another example. When they built this school, they did not build it and say, holy crap, that didn't work. Tear it down and build it again. Holy crap, that didn't work. Tear it down. Oh, man! But when they did finally build it, they did leave a few leaks in it. But that's okay. All right? Math has a place in the real world. You do 5 minutes of math, you save yourself 10 hours of work. And this is an example of it. Now, of course, this is a math question, so it's mathy looking. But it does have real life.
John
So,
has 12 apples.
yeah, exactly. Then how do you know how many apples to give Mary? Right? Okay, so my man, the farmer, has 100 meters of fencing. That's all he's got. It's sitting in the back of his fence. The deer are coming to, or the back of his barn. The deer are coming to eat the tomatoes, and he's mad. He wants to build a garden, but he only has 100 meters of fence. He has to, right? He has to keep those dirty deer out of his garden. CC? Everybody pick up what I put down there? Okay, just making sure. Some of you are like, yeah, you should build that wall to keep the deer out.
Oh, yeah.
I'm going to pretend that you're just saying that to bother me. So let us go on. So, here we go. Let's do some math. The garden is X meters wide. Find the length and area of the garden in terms of X. So what do we know about this garden? What shape will it have? A rectangle. Excellent. And the width is X. Do we know the length? No. So what should we give it? Y. Excellent. What do we know about X and Y? What's this over here? It's another X. What's this here? another y. So 2x plus 2y has to equal what? How much? Equal 100. Excellent. Now, do we want to leave it like that? We can leave it like that, but we should simplify it, right? What would that simplify to? X plus y equals 50. Is everybody in good shape? Okay. Now, have we solved the first one yet? Do we have the length of the garden and the area of the garden in terms of x? That's a math thing. What does this phrase in terms of x mean? You've got to get some value from what you've got, but it's in terms of x. What does that mean? You're giving it what variable? What is the variable that we are going to solve for? X. In terms of x means x is the one that we are looking for. So x equals blah. Everybody cool? So, what does x equal for length? Right. X equals 50 minus y. That is my length. Everybody cool? Does everybody understand that?
Mm-hmm.
Okay. What's area?
X times y.
X times y, correct? Well, x. What's the other one? 50 minus y. That will get me my area. Is everybody good to there? Is everybody good to there?
Yep.
Yeah? Yes? Okay. Can I do anything with this? Oh, it's not 50 minus y. Yeah. What can I do with that? I could expand it, yes? What's the problem with it? What? Because everybody understands why this works. Right? Everybody understands that. What's the problem with what we've written here?
Still two variables. A bit annoying because of that.
It's got two variables.
Yeah.
Right? There's a problem with this. Up until this year, this is what we've done, yeah? I have added this here, correct? Where do I have to do something there to keep my x's involved? Because I need a y somewhere, don't I? Where? Which step can I do something to get a y? There's 4 things written up there. One of those things will get me a y. What? Because this, Bryce has said, is ugly. Because there's 2 variables there. Right? I don't want 2 variables. I wanted terms of x. So what do I need to do to fix this up? Where can I get rid of an x? I mean, a y. Sorry. Can I get rid of a y in any of these?
Not easily. You don't have y, you can't really divide that.
What can I do right here? If y equals 50 minus x, does that get rid of our y? Why? Why does this get rid of y? Because where can I put that now?
Oh, I see. Gotcha.
Everywhere there's a y, correct? So what will happen here? What will my length become? What will my length become? 50 minus x. What will my area become? Area is length times width, correct? Right? What's my width? We already know it's what? Look at our diagram. What is our width? X. And what is our length? Y. But y is 50 minus x. So what goes here? 50 minus x. Now are we in business? Why? What is different here than here?
Wouldn't it be?
There's two x's. And we can do math with two x's, can't we?
Wait, if y, wouldn't it be 50 minus 50 minus x?
Because this is what x is. I don't need x. This should have been y. Right? Because length times width. Right? I needed this to be my length. This should have been x is 50 minus y.
Okay, got it.
So that should have been width. There we go. Now we're fixed up. Is everybody cool? So now we have our length and our area, yeah? So that's A. So B says what? Find the width of the garden with an area of 525. Well, what was my area? Area was 50x minus x squared, right? Because I expand that out. And what does that have to equal? That's 525. Does this have all the components of some math that we can do? What does it have? It's got a quadratic term, it's got a linear term, and it's got a constant. Is this in a form that we like? No. How would we make it look like something we're happy with? Move it around. How should we move it around?
Well, I don't like
I'm going to put it in the right order. Is everybody happy with that? Now what can I do? I can make x squared positive, can't I? Okay, so what would that look like? X squared minus 50x plus 525. Why does Lucas say that? Because when I moved it over, it becomes negative. Then I switch it to positive. Is everyone happy with that? Everyone's happy with that? Okay. Now, is that standard form? Can I do stuff with that? I can do all my quadratic stuff with that, can't I? Okay. Could I complete the square? Yeah. Could I run the quadratic formula? Can't even say the word. Could I run the quadratic formula? Yes. Could I put this into my calculator? Yes. Okay, so here's what we're going to do. First, for practice, we're going to run this through. Okay? Since that's 50, is it even? So is it a good candidate for completing the square? It is, isn't it? So I'm going to go x squared minus 50x plus what? 625, right? And then what do I like to do with this when I complete the square? I like to have it over here, right? So this side becomes positive 100. Is everyone okay with that? Wait, is it positive 100? Negative plus 625. Yes, positive 100. Is everyone okay with that? Okay, what do I do with this now? Factor it to get what? X plus it's always the thing you did here. X minus 25. Thank you, Lucas. And what does that have to equal? 100. Then I square root. X minus 25 equals 10. And what does x equal? 35 or negative 15, correct? Which of those can't possibly be? Which of those can't I have? Why not? Can I have a negative distance? If you were measuring the distance from me to you, the distance, can it be negative? No. What makes it negative? If it's a displacement, a vector, right? So what is x? Do I now know what y is? Because it's plus or minus 10, right? Because when I square root, it's plus or minus 10. Is everybody cool? Everybody cool? All right. And now C. What does C say to do? Find the maximum area, which means what? The maximum, which is a vertex, yes? How do I find the vertex? I've got vertex form here, don't I? Or what can I do from here? I could quadratic formula. That gets me roots. That doesn't get me a vertex. I can do negative b over 2a and sub in. Or I can do vertex form, which I have right here. Or I can plug it into my calculator, which is the last thing we're going to do. That's the whole point. That's why you all have calculators. Okay? So, what should I do here? I'm going to do all of them. Okay? So, the first thing I need is my vertex x, right? Which could be negative b over 2a, right? Which level of this do I get that? It's right here, isn't it? So what's negative b? 50 over 2, and what's a? 1. So what's the vertex? 25. Is everybody cool with that? Once I have that 25, where do I put it? Back into the equation, right? Where? Anywhere I see what? A y? An x, because this is my vertex x, correct? So I would plug that back in. Everybody cool with that? We do, because the y is output. Yeah. So I could plug that back in. Cool? All right. What else could I do? I have vertex form right here, don't I? We know the vertex is positive 25. Yeah? Is everybody good? Okay. So now let's find, now that we know how to do it mathematically, what would we do to put this into our calculator? This is where we're going to. Okay? So everybody get out their calculator. Where do I go to put this into my calculator? Y equals. What form can I enter there?
Standard. Well,
can I enter any form? Yes, I can. Can I enter it as this with brackets? Yes. Can I enter it as this? Can I enter it as that? Look closer. I got to move the 525, right? Because when we enter stuff into our calculator, it's always got to equal y. So that's where you got to be careful. Okay? So could I enter this one? That one's cool, right? Which one is the easiest to enter? Which one gives me the fewest button pushes? Have a look and decide. I'm going to highlight them. Is that one yellow, blue, or... Well, you can if you move it, right? Yellow, blue, or green. What gets me the fewest button pushes? Yellow, right? So how would I enter that into my calculator? What are you going to punch in? X, bracket, 50. What can you screw up right here? It's not a negative, it's minus. What? X, and then what? Close the bracket. Now, everybody's calculator right now probably has a different window, doesn't it? And when we hit graph, it's going to possibly look weird, yeah? Or it might not even show up. So that's ugly, yes? Now, here is where you guys are going to make mistakes. You're going to see maybe even a blank screen, and you're going to think you did something wrong. Did you? No. Where do we go to make it look better? Window. All right? The first hint I always say is to think about the question. Can we have any negatives? Can we have any negatives? No, we can have no negatives. So let's go into our window. Our x min is 0, our y min is 0. Is everybody happy with that? Change them. Because we can't have a negative length and a negative width, can we? All right, now, what's the longest x can be? 25, so then it would be 25 and 25, right? So x can be 25, correct? What scale should I have? You could go with 5, and that would mean each little tick on our graph was worth how much, Lucas? 5. Is everybody cool with that? Okay, now, I have my y maximum set at 7,000. Because the last thing I did on my calculator was the ticket question from the Quadratics, right? Which needed to be really high because I was making $7,000 on it, yeah? Do I need 7,000 here? What's the maximum length I could have? 25 again, yes? Now, should I use 25 and 25? Or should I go a little bit past? A little bit past, or it's going to go right to the edge of the screen, right? So let's make this 30. And let's make this 30. Now, can my scale be 700? No. What should my scale be? 5 again. Now I'm going to graph it. Oh my God, what happened? What didn't we do big enough? There's only X's and Y's. What did we screw up? What did we screw up? What is this graph measuring? Is it measuring length versus width? No, what's it measuring? Length and area. Right?
So it would be 625 or 630.
Well, we can, but we've screwed up our window because we were thinking in terms of length and width. It's not length and width. It's width and area, isn't it? Our y value is our area, right? Because this equals area. That's my output. So when I go to my calculator and I check my window, we did this for length and width. What is y? It's our areas. We know that our area is at least 525, don't we? So what do we got to do? Make it what? 600? Okay. Now the reason I'm doing this to you guys is because there's no right or wrong way to teach you how to use the calculator. I'm teaching you how to read the calculator. Okay, you want to go 650? And what should we have for our scale then? Does it really matter? You want to go 50? What does that give us? Is that graph going to work for us? Yes or no?
Yeah.
Why? Because it gives us, we can see our maximum. Even though I'm short and can barely reach it, if I didn't have the pen, I couldn't do it. See? I got, oh, wait. There. Oh, I can't stay like this very long. There we go. I can't stay like that very long because last night at karate, my wife kicked me right in the knee. Nice. I was kicking this way, and she was kicking, but she finished her kick first and put her shin right into my kneecap. Hurts
worse
a lot. And look at this.
Oh, nice. Sweet.
Some like 12-year-old. I think she broke my hand because she kicked me really hard. Look at that.
Pro tip: don't block with your hand.
I was blocking. She was kicking. Little kids always do that because they don't have control.
They don't have power control.
Right? Yeah.
Same with new people.
Yeah. I can punch Bryce so hard he wouldn't even, like, it would kill him. But I could just touch his nose. But if I really hit him, little kids are at
All the time.
all the time. Huh? Yeah, my wife when I punched her in the nose. So, now can I do this? We know this is going to be, we know what it's going to be, yeah? We know that it's going to be 25 for x because of what we did. So, second, calc, what do I want here? Maximum. Now, I'm going to show you guys something here. So, I got to tap it a million times. You guys are probably already there. Because I'm on the left, then I'm going to tap out here and get on the right. Once I go over the hump, once I start going back down, I'm good. Enter, enter. And guess. When x is 25, y is? So that's the biggest area I can do. And it's at x is 25. But I want to show you something on your calculator. We already knew that it was going to be 25, didn't we? Watch. Second, calc, value. What x value do I know to put in there? 25. 625. Everybody cool? So what I'm trying to get at here is, even though you could do all of this on the calculator, if you do a little bit of math, you can make your calculator life easier. Okay? And here's why. Watch what I'm about to do. I'm going to change the window. Okay? See how my window is totally screwed up now? You can just see the beginning of the parabola, yes? Because this is a 10 by 10 window. You can still do it because you know it's 25. So if I go with a bad window, second, calc, value, 25, because I know that's my Vx, does that not work on everybody's machine? Second, calc, value. It worked on my old TI-81. Okay, so You still got to use the change your window. Damn it. Okay. Oh, now it's frozen. So you guys go to the next question while I fix my machine up here. The next question's weird. Why? Yep. T and H means what, though, Joel? Time and height. Are they still X's and Y's? Sure they are. Yes. Yes. So, here is my equation. What's wrong with that?
I don't like that decimal.
There's a decimal. So are we going to bother doing math with it? We could, couldn't we? Jenny, we could, right? We could make that. We also don't like the order here, yes? How would I write this so we would be more comfortable doing math with it?
With less.
Negative 4.9 t squared plus 24t plus 1. Now, if I gave you this, would you attempt to complete the square?
No, I wouldn't.
Would you attempt to factor?
Nope.
What is the only math option you really have here? Quadratic formula. Why is the quadratic formula I can't say that word today. Why is the quadratic formula yucky for this? Why is it yucky?
It's still a decimal.
Because there's still a decimal in it, yeah? So when it looks like this, we're going to go straight to our calculator. Can I put that into my calculator? Yeah. So when I go to my calculator, I go to Y1 and I enter this. How are you going to screw up entering it? You're going to screw up that negative sign. What is this one? Is it that or minus? It's this one. So we go into Y, we clear out our old one, negative 4.9. Now, we've been using X. Now I have a T. Does it matter? Of course not. I still hit the variable button, squared, plus, was it plus? 24, and plus 1, yes? Now, will this work with the current window I have? Remember, I've set mine at 10 by 10. Graph. Oh, crap. Well, it kind of did. So what is the only thing I need to change here? What should I do with my calculator? What do I need to change? Do I need any negatives? Why? Because it's time and height. So I'm going to go to my window. I'm going to get rid of my negative x's. I'm going to get rid of my negative y's. Now, you guys got to use your head. Will 10 seconds be enough for a ball to hit the ground?
Yeah.
Maybe. I don't know.
20 meters? Yeah, probably.
So let's leave it at 10. And how much height do I need, do you think? You want to go 30? Are we happy with our scales of 1 and 1? Let's see what happens. Oh, did I make it? Not quite. So what do I do? What's got to change? Are my x's good? So what's got to change?
You don't need that last pixel.
Just my y's. So if I make that 40, am I going to be okay? Sim sim salabim. I am. So I enter this in my calculator. Watch out for negatives. For negative or subtraction. Then I check my window. Then graph. Now, I want the maximum height for the ball. So that's second calc. Now, can I use the value feature today? No, why? Because this math was so hideous, we didn't bother finding our Vx, did we? So I'm going to go second, calc. What do I need? Maximum. And then I do my draw, or I use my arrow keys.
Oh, I guess I do.
Not quite. It was a bounce question, yeah. Or a drop question, I can't remember. So there's my cursor. I'm looking for my left boundary. How far to the left do I have to go? Soon as it's gone over the hump. Enter. Right boundary. Soon as I go over the hump.
What's that, a drawing you got there?
Soon as I go over the hump. Enter, enter. What's my maximum?
30.3.
387. Maximum. And what do I get? 30.387, right? So 30.39 meters.
Why is there no calculate button for like when y equals up?
Okay. Yes, Lucas? Enter again. And then B, for what length of time will the ball be higher than 20 meters? Now that gets weird.
It'd be easy if you had to calculate y, negative subtract.
Time. Time is on the X, yes? Okay, so can I use the value button? No. I need to know when the height is over 20, yes? Where do we measure height, on the Y or the X? So go back into your graph here, go down to Y, and hit Y equals 20, and look what happens. So what do you know about that point right there? That's where it hits 20. Does that have an X value? Does that have an X value? So all this time in here, it's over 20, isn't it? So just wait. Hit second calc. And have a look at your choices. What ones do you think are you going to use? You could find the X and use value. How are you going to find the X, though? Because look on your graph. The X is yucky, and we don't want to do math. You don't know what that X is exactly. You could hover your cursor over it. That's one thing you could do. But that's not going to be exact, is it? Because when we move that cursor, does it move? It moves in chunks, doesn't it? Okay, so it'll give us an idea, won't it, Joel? But it's not going to be exactly right. So what here again? So it's not going to be value. It's not a 0. So what is it, Bryce?
It's an intersect.
It's an intersect, isn't it? It's where our curvy parabola hits what? Our straight line, yes? So see what happens when we punch that in. 5. First curve. What's the first thing we graphed? The line or the parabola? Parabola. So I'm going to use my cursor to get onto the first curve. Do you see that it is on it? Okay. So am I close, like Joel says right now? So I'm going to hit enter. Second curve. Am I on it now? Am I on the line? So I'm going to hit enter. And then it's going to ask me, should it guess? Do we want it to? What does that give me? My Y value is 20. Is that what we want? And the time was 3.9. Or the X was 3.9. So at what time does it go below 20? 3.9. I then just need to find the intersect over here. And then I know the times. Because you subtract them. Everybody good? So you all go ahead and find the other one. So we know that 3.9 is one of them. You go ahead and use your calculator to find the other one. Joel already has it.
Yeah,
It's straight 1.
It's point. Well, I got 0.992.
Enter, enter, enter. So I got 0.99287. So that's 1 second, yeah? So 1 second to 3.9 seconds. Does everybody understand?
2.9 seconds?
Yeah, so 2.9 seconds. So where we are now in pre-calc 11 is if there's no decimals and fractions and stuff, we can do everything with parabola, yes? If we encounter decimals and fractions and stuff, what do we go to? Which calculator? Your fancy schmancy one. And on your fancy schmancy calculator, what are the buttons you are looking for? You're going to be using second calc. So far we've used max min, right? Value and intersect. Now the only trick I taught you there was this trick. That second line I put in there, right? Everybody cool? Okay. So you guys are going to do, it's 10:54. You guys, I want you to try, oh, that's a typo. That -1 exponent there should not be there. That's supposed to be 35 kilometers an hour. Sorry about the -1.
I think that's actually 3.5 kilometers an hour to the -1.
You want to do it that way?
I mean, it's there.
3.5 kilometers an hour downhill. She's not riding very fast. Not a very big hill. So, here's what I want you guys to do. Page 116 to 118. I lie, 119. That needs to be done by the end of tomorrow. Okay? This will be marked in class Thursday. You're going to work on it tomorrow. Now listen, please. Thursday is a short day, yeah? So we're going to mark that and go over it, right? Make sure everybody's comfortable with it. The rest of Thursday's class is going to be page 120, where we do our test reminders. This question, I want you to try this tonight. You really can't do it very well without a calculator, so you don't have a fancy calculator. You don't have to worry too much. Try this tonight and look at how much work I am asking you to do tomorrow. If that is going to take you longer than 80 minutes, you better do some of this when? At home tonight. Because I am marking this at the beginning of Thursday's class. All right? So you really have 2 nights to do it. Okay? Now the bell's about to ring. Is everybody cool? Return the calculator. Get your who's a what's it back? Your phone.